Hi, my name is Jonathan Charles, and welcome to Performing a Migration Part 1. Stay tuned for Part 2, because this is kind of longer. So, in many networks, SD-WAN isn't going to be deployed in a greenfield environment, basically an environment where there's nothing there already. It's going to be brownfield, where there's already an existing network. So this is why it's important to understand how to introduce SD-WAN into an already operational network. We're going to discuss various migration scenarios, which includes introducing SD-WAN into the data center, so those SD-WAN branches can connect back to the data center, introducing SD-WAN into the branch office sites, replacing those legacy customer edge devices, and ensuring the coexistence of traditional WAN and SD-WAN devices. And when we're done with this, you should be able to describe how how to enable SD-WAN in the data center, and the use cases for migrating all those branch sites into a pure SD-WAN environment. So, in a traditional data center design, core switches connect the WAN edge routers and the firewalls. The WAN edge routers connect to the transport circuits, and branches are in turn connected there. This is traditional. It's a little simple, but this is the traditional setup. To support both traditional and SD-WAN branch offices, the data center must include SD-WAN devices, which are connected behind the WAN edge devices, seen from the transport side. Okay? So basically, the SD-WAN devices are going to be here. Our core switches are going to connect to them. Then the SD-WAN devices are going to connect to the CE devices and the firewalls. Okay? So remember, these transport circuits aren't going to be connected directly to the SD-WAN devices. They stay connected to the existing MPLS CE routers and your existing firewalls. So we're not making any modifications here or here. We're putting the SD-WAN devices behind your existing SD devices and then connecting to them through that. And then the SD-WAN devices connect to the back of the core switches, and the SD-WAN devices set up tunnels between various sites following the SD-WAN policy. Those tunnels effectively form the overlay topology. The core switches will control the traffic via two principal paths because we have redundancy. The direct path core switch, WAN edge transport, bypassing the SD-WAN devices. So this is the direct. The path through the SD-WAN devices, this guy. Now the core switches can route easily between non-SD-WAN sites, choosing the direct path, or SD-WAN sites choosing the path through the SD-WAN devices. So for example, this site has not been migrated to SD-WAN yet. It's still going to connect through the existing MPLS cloud. This site has been, so it's going to connect through the overlay network that we just built. A step-by-step procedure on how to introduce an SD-WAN router in the data center starts by connecting the SD-WAN router with two links to the existing CE router. VPN 0 for tunnels and VPN 10 for the service side. So the way this would work is, so our SD-WAN routers here, we have VPN 0 connected to an interface on the router that connects us out, and VPN 10 is connected to another interface on the router that connects us back into the inside of the network. From an SD-WAN router perspective, the customer edge router is simply part of the network around it and is not SD-WAN aware. Initially, the CE router does not use the links to the SD-WAN router. It now has the choice either to route directly to the transport network, which would not be an SD-WAN connection, or over to the SD-WAN router to pass over to SD-WAN sites. So from your switching perspective, you would connect directly this way, and if the MPLS were to go down, we can then route through the SD-WAN overlay. Routing is now set up such that SD-WAN prefixes are announced to the CE router, and from the CE router to the SD-WAN router. So we're going to be doing mutual redistribution here. So all those OMP routes are going to be advertised back into the CE router. Meanwhile, our MPLS learned routes and our service side routes are going to be advertised back to the SD-WAN router. So the SD-WAN router will see those routes as local VPN routes, which belong to a service VPN, because we learned them on VPN 10. The SD-WAN router redistributes those routes to other SD-WAN sites over the SD-WAN tunnels through OMP, and we'll advertise those out to our SD-WAN sites. Remember, we're talking about a migration here, so we already have all this, infrastructure in place, and we're adding SD-WAN to it. The return path is going to work in a similar way. SD-WAN prefixes are received from other SD-WAN sites through the tunnels and redistributed locally into the local site routing protocol on the service VPN. And the CE router is going to receive those routes and redistribute them to non-SD-WAN sites. Be also aware that we may need to add filters on the CE routers to prevent routing loops if we're doing the same migration at other sites at the same time. Now, the SD-WAN traffic is routed correctly as follows. From the data center, SD-WAN traffic is routed to the CE, which routes to the SD-WAN router via the link on VPN 10. Back to the CE router on via VPN 0 on the vEdge. So we're actually going to hairpin on two separate links. Remember, these are not the same interface. This is two separate either interfaces or sub-interfaces. Redistribution into OMP happens right here because we've got the link routes occurring. And traffic is sent to the corresponding SD-WAN site through the tunnel. Alternatively, for SD-WAN traffic to SD-WAN sites that are connected over the MPLS transport, the SD-WAN router uses a tunnel over the MPLS transport. So this tunnel right here. And I know we're getting a little busy here. Traffic to non-SD-WAN sites goes directly. Without touching the SD-WAN router, Traffic to non-SD-WAN sites, these are the non-SD-WAN sites, go directly without touching the SD-WAN router. Remember, the CE router is actually handling our routing decisions. So it's learning SD-WAN prefixes via the VPN 10, and VPN 0 allows the SD-WAN router to also connect to non-SD-WAN sites using the MPLS. If, for instance, your site is over here, connected to the MPLS network, but not connected to the internet, we hit the CE, we have prefixes that are learned over the MPLS, so we route directly to it. If we have an SD-WAN site, we have prefixes that we learned via the SD-WAN, and we route directly to that. So the only downside here is that hairpin routing from the CE to the SD-WAN and then back to the CE is going to be suboptimal because traffic hits the CE twice, therefore routing to the CE is more complicated. A final step here is to connect the SD-WAN router straight into the DC core switch, avoiding going through the CE twice. However, now we need to do our routing on the switch because the traffic isn't going to go to the SD-WAN sites. Sorry, for traffic not going to the SD-WAN sites. So let's do an example of how to introduce SD-WAN into a branch site. And we assume one internet, one MPLS connection. The goal here is to replace that CE router. Before the migration, the flows go over the MPLS transport to other branches, and a connection to the internet serves as a backup path. Okay? So basically, we have a core switch, a CE router, and then the CE router has two connections. In the migration, first the SD-WAN router replaces the SD-WAN CE device. Okay? So we're going to take that CE device and replace it with an SD-WAN device. The SD-WAN device is going to establish tunnels over the transport networks to the remote sites, which in our example is a DC site. Right? So we'll have SD-WAN connections over both internet and MPLS to our data center site. Through these tunnels, the SD-WAN device learns about other routes from SD-WAN enabled sites, as well as from non-SD-WAN sites via MPLS. These routes are redistributed locally from OMP into the local routing protocol. This way, the local LAN has all prefixes to other sites. The local LAN prefixes are announced first into the local routing protocol, then redistributed into OMP and sent to other sites, including non-SD-WAN sites. And this allows traffic to flow to the sites. Okay? So for example, the DC remote sites are going to have MPLS, and we're going to have that connected directly to it. In our example, the connections to the non-SD-WAN sites goes through the data center, right? And you can actually see this hairpin up here. The local site receives all routing information the same way for SD-WAN and non-SD-WAN prefixes. Okay. So in this example, a direct connection to a non-SD-WAN site is going to be required, such that traffic to MPLS VPN sites doesn't cross the overlay tunnels. To achieve this, the underlay routes in VPN 0, which lead to remote MPLS VPNs, are passed through to that local LAN. The left side of this graphic shows the SD-WAN route propagation using BGP to OMP to BGP, OSPF to BGP, etc. The right side shows the propagation of MPLS VPN routes. They're not received over SD-WAN tunnels, but directly through the underlay. To facilitate communication between the MPLS network and the local LAN, a separate VPN 0 interface is provisioned on the SD-WAN device. So you'll notice we have a VPN 0 interface here and another one here. Thus, traffic stays on VPN 0 on the SD-WAN device and no redistribution is required. Note that second link on VPN 0 going to the switch, this guy right here. Note this architecture facilitates a direct connection between outside and inside of the branch, which may have security consequences. Generally, for most sites, it's preferable to route all traffic, SD-WAN and non-SD-WAN, to the data center over the SD-WAN tunnels, as shown in that previous example where we did the hairpin. One potential issue here is that traffic from non-SD-WAN sites to SD-WAN sites might transit through the local site. To avoid that, make sure that the non-SD-WAN prefixes learned from the underlay are not propagated back into the SD-WAN overlay. And the problem might be here is that if I learn a route this way, I don't want to then have this guy advertise that route over that way, so that people use us as basically a transit AS, if you will, because we're doing mutual redistribution. So the only prefixes that should ever be announced from this guy are these local LAN side prefixes. Okay? And that should be the case with any remote site. Unless you're advertising some other backup reachability, you should never advertise anything other than your own locally owned LAN prefixes. Consequence of this setup is now traffic to SD-WAN sites goes through the SD-WAN tunnels, and traffic to MPLS VPN sites goes straight through the underlay. So in summary, you can upgrade data centers to support both SD-WAN and non-SD-WAN branch sites in parallel and assure interoperability between the two models. And we can convert and migrate branch offices to a pure SD-WAN. Thank you for watching, and stay tuned for more content.